man starts at point A and walks 3 kilometers on a bearing of 030 degrees to point B. At point B, he turns and walks 5 kilometers on a bearing of 110 degrees to point C. We want to find the distance AC, the bearing of C from A, and the bearing of A from C. The first thing we need to do is produce a diagram. So reading the first line of information, a man starts at point A and walks 3 kilometers on a bearing of 030 degrees. We start with a north line, and from north our bearing is 30 degrees measured clockwise, and he walks 3 kilometers. So this is our north line. Our bearing measured clockwise from north, this is point A, and he walks to point B. The second line says at point B he turns and walks 5 kilometers on a bearing of 110 degrees to point C. So we need another north line at B, and then he's going to walk on a bearing of 110 degrees, again measured clockwise from north, to point C. Here is the point C. He walked 5 kilometers here, 3 kilometers from A to B, and the bearing 110 degrees measured clockwise from the north line. Now that we have all of the information from the question on the diagram, we need to derive some further information from the information we have. The first thing to look at is the two north lines. North lines are parallel, and therefore we have co-interior angles which we know must add to 180 degrees. So this angle is 150. We then have angles round a point which we know add to 360, making this one 100 degrees. We now want to use this information to work out the length of AC, which is part A of the question. Since we want this length, it makes sense for us to call it A. The angle opposite then we'll call A. If we call this angle B, this side is B, and we have C and C. So we've relabeled the triangle to fit with the formulae that we get given in a formula sheet. Listing out the information given, we have angle A and side A, angle B and side B, angle C and side C. Angle A we know is 100 degrees. Side A we want to find. Angle B and C we don't know. Side B is 5 kilometers and side C is 3 kilometers. This means we need to use the cosine rule since we have no opposite information, and since we're finding a side we state it as a squared equals b squared plus c squared minus 2bc cos A. We can now substitute the values into the formula, so a squared is 5 squared plus 3 squared, take away 2, times 5 times 3 times the cosine of 100 degrees. This gives us that a squared is 39.209 and so on, and taking the square root of both sides we get 6.26 and so on, and this rounds to 6.26 kilometers, correct to 3 significant figures. As you can see here, the triangle has now been updated with the new information. For part B, we want the bearing of C from A, which means this angle measured clockwise from the north line. We therefore need to calculate this angle, the angle B, and if we again list the information we know in the triangle, angle A, side A, angle B, side B, angle C and side C, A is 100 degrees. We've now worked this out as 6.26 kilometers. Angle B is what we're trying to find. Side B is 5. We don't know this angle, and this side we know is 3. We now have opposite information, which means we can use the side rule. And since we're finding an angle, we'll state the sine rule with the angles on top. So sine A over A is sine B over B, which is sine C over C. We're going to use A's and B's, so we don't need the C's. Substituting in, we've called the angle B that we're trying to find x, so sine x over 5 is equal to the sine of 100 degrees divided by the side opposite it, which is the 6.26. This gives me that sine x is 5 times the sine of 100 divided by 6.26. Calculating this gives us that sine x is equal to 0.786 and so on, and to find the angle x we need the inverse sign or shift sign on the calculator of this number, and this gives us 51.9 degrees to 3 significant figures. This is the angle B, so the whole angle we want is that add 30, which is 81.9 degrees, or a bearing of 0.82 degrees to the nearest degree. Finally, we want the bearing of A from C. If we draw a diagram, here's the north line, and this is the point A, and C is over here, and we can draw a north line at C. This bearing we've worked out is 82 degrees, and again using co-interior angles, we know the sum of these two angles must be 180 degrees, so this angle is 98 degrees. Bearings are given clockwise from north, so this is the angle we want to give, and it's 262 degrees. So the bearing of A from C is 262 degrees.